Hello, everyone. Welcome back to the good stuff you've been doing. This is question 9 from the WAEC 2008 mathematics. So let me write that above here. So we have 2008 mathematics. So this is question 9. And the A part is what we're going to work out first. It says we have a triangle ABC 17, 12, and 10. And we are going to get the largest angle in the triangle. So let's see. We draw the triangle. Let me raise it up. Okay. So that's the triangle, and it's triangle. Let's call it triangle A, B, and C. The largest side is 17, and then this side maybe 10. This side is 10, and this side is 12. And then we are going to say the largest angle. Now, when you hear this largest angle, just know one thing. It is that angle facing the largest side. Like this is its largest side, 17. So this angle here, which we just do it like this. This is the largest angle we are looking for, because the triangle, the largest angle is always facing the largest side. So this is a triangle. So this angle is the largest here. It's always facing the largest side, which you can see from the illustration. We may even use this figure here. Let's say this is 17, this is 12, and then this is 10. So this is 10 and this is 17. I even like this figure. This one is looking more like a right triangle, so I'll just wipe it off. So here we have that this part here is 17. Here is, let's say, 10, and then this is 12. So let's say this is a triangle, and then this is the largest angle. That is what we are looking for. But for the I part, later we find the area of the triangle. Then how do we get this largest angle? Where is, because of the way the triangle is written, we are going to make use of a very important theorem. Let's say this is A, B, and C. Then there is something called the law of cosines. And this law of cosines says that if you have a triangle here, say this is a triangle, and this side is an angle, let's say this angle, and this is A, B, and C. And then we may label this side A as small letter A, small letter B, and then small letter C. The law of cosine says if you want that this side A, the square of A square, is similar to the Pythagoras theorem where we have B square plus C square. We will then have minus 2BC cos A, the cosine of the angle A. So like in our figure here now, assume that you will label this part accurately. Let's say this, let me get a figure like this one, this large one we have here now. So this is the figure here. Label this is C, and then we call here C, and this is A, and let's call here, no, it's too far. So this is A, and let's call here A, and then B. Let's say this is B. Then what we have is that C square is equals to A square plus B squared. No, sorry, this is B plus B squared minus 2A times B cos C. Now you may be asking me, how did I get this formula really? Like, where did this A come from? Where did B come from? Where is this 2AB? Where is it coming from? And I will tell you how I did get it. So let's go down a bit. Remember the Pythagoras theorem, which says that if you have a right angle triangle and this side is A, let's say this is B, and then we have a C here, and then this is C, B, and then A. This theorem says that C square is A square plus B squared, where this case is only true when this angle here is 90 degrees. On the other hand, suppose the angle here is not 90. Like say this angle here is something else, and then this is C, this is A, and then this is B. Then for this case here, this formula here, if this is C, this is A, this is B, this C square would be equals to A square plus B square. Just like the Pythagoras theorem, like the C square is always this side and this side. But in this case, because the angle is 190 degrees, we subtract 2AB, we multiply A and B, 2AB, and the cosine of that angle C cos C. So that is what we call the law of cosine. So the law of cosines is applied when the angle is not 90 degree. When the angle is 90 degree, like in this case now, we use the Pythagoras theorem. So this is Pythagoras theorem, but this case, this is the law of cosines. So yeah, we subtract minus 2 ABC. This is not really hard to prove, and I'll show it to you. Like, let me prove the formula. Though it will waste time, but it's worth learning. So let me prove the formula. We'll get back to the question. Let me erase everything. Okay, so let's see. For the proving part, we can recall that if we have a right angle triangle where here is angle 90, the Pythagoras theorem says that this side C squared is A squared plus B squared. But if this angle is now obtuse, just like this second figure here, if it is now obtuse, no longer right angle, we can no longer use this formula. Like if here is C, even though here is A and then here is B, we cannot say that C squared is A squared plus B squared. Pythagoras theorem only holds when the angle is 90. So what do we do when the angle is not 90 degrees? Well, let's see. We will still try to make it 90. Let's extend, assume that you extend this part. Let me use a different color. Okay, so assume, let's say put a red, you extend this down over here up to this part here, and then where it happens that this angle here is 90 degree, like we extend it bottom. Let me try to make it as accurate as I can. So I use a ruler. Let's see. Yeah, fix it. So I'll try to make it as accurate as I can. So assume we drop a 90 degree angle here, and let's say, first of all, we don't know this x, this part here, this part. Let's say here is x, and let's say here is our y. We don't know these two sides here. Now, if this was this triangle, this point D, let's say this point is D. I'll write it in different color. Let's celebrate in black. This point D here now, as we are seeing it, if this part with consider triangle B, D, and A, then if we use the Pythagoras theorem, we will have that C squared, first of all, by the Pythagoras theorem. I'll write it here to get more space. We'll have that C squared will equal, first of all, we'll get Y squared, then plus this X plus B, because this length DA is not just B but X and B. So we'll have X plus B, we'll have R squared. Now this theorem is just this, no, wait, let me fix something. Now what we just did here, this formula we just fixed here, is just similar to what we have above, where we have C squared is A squared. This C squared is A squared plus B squared. Same thing as C squared is Y squared plus X plus B squared, because this length here is X plus B and this part is Y. So when we try to expand this formula, what we have here is that C squared will then be Y squared. Now if you remember how to do this, this will be plus S squared plus 2bx plus B squared. Now I will just put it as C squared is equals to Y squared plus X squared plus B squared, now plus 2bx. Now let us remember that x squared plus y squared, if you use the Pythagoras theorem, it will equal a squared. So here C squared is a squared plus B squared, now plus 2bx. Now see the similarity between this formula here and this formula here. Just the same thing, but then we have an extra 2bx term here. Now how do we deal with this 2bx? The quickest way is to find the value of x, because this is not the real formula for C squared, because C should be, the way C is in terms of A and B here, C should be in terms of A and B as well. X, we don't know. X actually just came into the equation by chance when we had to do extra construction, so we have to eliminate x. And the quickest way to do that is that, notice that since here is, let's say, angle C, this is angle C, or let's say this is theta, because this is a straight line, this part is now 180 degrees minus theta, this small angle here. So this x here now, if we take the cosine of this angle, cosine of 180 degrees minus this theta. Now let me write this in clear so you can get what I mean. what I mean is that because here is theta, this part here should be 180 degrees minus theta, because angle in a straight line, they are both in a straight line. They should add x plus y should be 180. So this theta here and this small angle here should give us 180. So this angle is 180 minus theta. So the cosine of this angle is x is equal to x all over the hypotenuse, because cosine is adjacent over hypotenuse. So x over a. So x, now notice that this is minus cos theta, because cos 180 minus theta is negative cos theta. Now if you don't get why this is so, I really just recommend you just take it as faith, like just believe it because it's true. But then you can still ask me, no, I will still do more videos in trigonometry where this thing I explain, but just for now, let's just take it as true. This is x over a. So if we multiply both sides by a, x would then be negative a cos theta. So this formula will be c squared equals to a squared plus b squared. Then we have minus 2ab, because this cos theta, in the sense that theta will come, so like this case, theta will come here, like this is a cos theta. So b here we put a cos theta in place of x and the negative part. So we just get this. And notice that theta is this angle c. So therefore we may say that c square is simply a square plus b square minus 2ab cosine of c. And this is the law of cosines. Having equipped with these two, we can now tackle the I part of the problem. So let's go and see, look at it here. So yeah, it says that we should find the largest angle of the triangle, and I already told you that this triangle here, which is more like this, c squared is a square plus b square minus 2ab cos c. So let's use it and see if we can get the angle. Let me wipe the board. So now that I've wiped out the board, let's continue with the solutions. Here we are saying that the formula to use here is c square is a square plus b square minus 2ab cosine of c. The reason we're using this formula is that usually it involves cos of an angle. We know c, a and b, so we can just use this to find the cos, the value of cos c. But before I plug in 17, 10 and 12, I'll first of all arrange it. I'll put this as 2ab cos c is, then I'll bring this as c square minus a square minus b square. More like I brought now how do I, okay, like, wait, sorry about that. I think I've really blundered a bit here. Okay, let's see about that. Now, okay, let's see. Let's bring this over here and c square over here. So this will be 2ab cos c is a square plus b square. Then we have minus c square. If we divide both sides by 2ab, then we'll be having that cos c. We should be having that cos c is, I'm coming about a bit. Okay, sorry about that. So if we have 2ab cos c to be equals to a square plus b square, then minus c square. Then if we divide both sides by 2ab, this cancel out. Then you have cos c would then be a squared plus b squared minus c squared all over 2ab. Here, if you just take note that c is 17, b is, let's say, 12, a is 10. They can be like a and b may be interchanged, but c is always fixed. Then cos c would then be equal to a squared plus b squared, that is like 10 squared plus 12 squared, then minus 17 squared, right? All divided by 2ab. So let's see how we deal with this case here now. All this will equal negative 45 for the numerator. Now this 2ab is just 2 times 10 times 12, right? Yeah. So here we see that 5 here is 9, and then 5 here is 2, where 3 here is 3, and then 3 here is 4. So this is 16. So this is negative 3 over 16. All in all, what we should be having is that cos C, let's see, what we should have is that cos C is negative 3 over 16. Then that means C is 180 degree minus cosine inverse of 3 over 16. Reason being that, remember when I told that cos 180 degree minus C is negative cos C. So that when the cosine is negative, 180 degree has to come in the place. So this is 180 degrees minus, now like that, now cos inverse, when you punch your calculator for cosine inverse of 3 over 16, what we get here is 79.2 degrees. So this is 79.2 degrees. So this is equals to, now 180 minus 79.2 degree, 79.2 degrees is just approximately 100 points. So this is 100.8 degrees. So that is the value of the largest angle. So this largest angle is just simply 100.8 degrees. Of course, you can see that it's greater than 90 degree. So it's obtuse. It's not equal to 90. It's more than 90 degree. So that is for the largest angle. I think that is all for this video. In the next video, we're going to find the area of this triangle. So thank you for watching, and please subscribe to the channel. Have a nice day.